My name is Craig Raw. I am the developer of an open source Bitcoin wallet called Sparrow Wallet, which is available at sparrowwallet.com for free. It is a desktop wallet which you can use to basically take the Bitcoin that you might buy on an exchange and transfer it so that you hold it with your own private keys and in your own capacity.
Why did you create the application yourself? Wasn't there a good one?
There were a few, but the monetization of Bitcoin wallets is not an easy path. And so there weren't as many as you might think. And I found the ones that were available at the time were not ideal for the use case that I particularly had at the time. So I felt that they were a bit clunky and not confidence inspiring enough. And when you're talking about money, you want to be feeling confident that the application you're using is trustworthy in the sense that when you're using it, you understand what it's doing. And that's really what I tried to create with Sparrow.
Yeah, you mentioned something like that on the website. It is not about hiding information, but showing as much as possible about what's happening behind the scenes. So is this also, putting your data in that blockchain, waiting for the results? All these things are visualized in the app?
That's correct, yes. So Sparrow tries to show you as much as it can. It really actually tries to educate you about what you are doing as you're going along with it. So when you're a new user, you generally tend to look at Sparrow and just use it and ignore some of the more advanced information that it's showing you. But as you use it over time, then those pieces of information start to become clearer and you start to developing a deeper understanding of what you're doing. And really, when you're talking about managing your money, you want to really understand what you're doing. The difference between Bitcoin and the traditional fiat world is that when you move into the Bitcoin space, you take responsibility for your money in a way that is quite different. And as a result, that responsibility comes with a lot of freedom, but it also comes with the desire to really do it the right way. And that's what Sparrow is trying to do and help you do.
This calls for a demo. Can you show us how Sparrow works, what you can do with it? I hope not by you spending a lot of money. I guess you have some demo mode to show.
Yes, so happily, the Bitcoin network has a number of test networks where the money effectively has no value. It's just numbers that you can transfer around. So I'm going to use one of those now. It's called testnet 4. So what I'm going to do is create a new wallet. So basically, just give it any name. So we're just going to call this one, say, JavaFX. And that opens up a screen here where we see a number of different options. As I said previously, a lot of this looks quite complex, but you can kind of follow along with one of many tutorials that are written. And generally, the guide is to click the blue button. In this case, we're going to have a simple wallet. I'm going to ignore these two drop downs here at the top. And we're going to create a software wallet where the private keys to this wallet are stored on the computer itself. They're not stored elsewhere on a hardware wallet or some other device. So I'm going to click that. We then have a number of different options here that we can use. The most usual option is to use a set of words. So for example, 12 words. So I'm going to select 12 words here. And then that gives us a word. Now, what this really is just representing a private key with a number of English words. And in order to do this, I'm just going to use generate new. And that just really creates a long random number, which it then translates into these words. So that gives us these words here. I can then say confirm backup. Now, what I'm going to do here is just copy these words down into a text editor. Now, normally you would not be doing this. Normally you would be writing these words down. But I'm just going to do this because it's going to save us some time.
So these 12 words are the way to retrieve my wallet, even
That's
if I would
correct.
lose my computer, or like all these horror stories of USB keys being lost with passwords. So this is the thing you should be keeping forever and ever to retrieve your wallet, correct?
That's right, yes. So effectively, you would be writing these down on paper, putting them in a safe, or even better, putting them onto some form of more durable media. You get all these different products, which are steel plates or sets of washers or all kinds of things that rarely let you put these into something which is designed to withstand fire and all kinds of different disasters and just last for a really long time. So I've copied these down. It's asking me, have I copied them down? Because I'm going to have to re-enter them. So then I re-enter them. I'm just going to paste them all in again. And then we're going to say create key store. And that there's a bit of detail here, which we're not going to go into. We're just going to follow the idea of the blue button. We're going to click that, and then that has now imported this as a software wallet into Sparrow. So we've now created this private key wallet within Sparrow. And these are some details about the wallet. Again, we're not going to go into the details about that. I'm going to click apply. We can set a password here. This password just sets a password on the wallet file, which is a database. So it's not really doing anything but protecting the details on this particular computer. It's not going out to the Bitcoin blockchain or anything. I'm not going to set a password on this now. I'm just going to click no password. You can see all of this has now lit up in blue, and that means we now have access to all these different tabs. So I can click on the transactions tab. Obviously, this is a brand new wallet, so there's no information in it right now, but there's information we can go through and we can send, we can receive, and do various things. What I'm going to do now is just open up another wallet which already has funds in it, so we can kind of get a bit of an idea on how we can send and receive in Sparrow. So I'm going to click File, Open Wallet, and I'm just going to open up this one here, which has just got a bunch of test transactions in it, and I'm going to then use this just to send to the wallet that we have created. So we're going to click on the Send tab here, and we can then select. Normally, this is where you would paste in an address. So for example, I could go back to JavaFX, I could click on the Receive tab, and I could just copy this, which is the first address in this new JavaFX wallet. And I can go back here, and I can just paste it in, right? So that immediately puts that address in. I can say, let's say, fund JavaFX wallet. Now, this label doesn't, again, go anywhere but your own wallet. It's just locally for you to use. So fund JavaFX wallet, and we're just going to transfer an amount. Now, in Bitcoin, we think about amounts. The base unit is a Satoshi, and there are 100,000 of those in one Bitcoin. So you can obviously send around small fractions of a Bitcoin. So I'm really going to send a small amount through. I'm going to send, say, 1,000 sats through, very small amount, to this new JavaFX wallet. Now you can see here that we now have to set a fee, and we've got a fee range here, which we can control up and down, right? Normally, because we're on a testnet network, 1 sat per VByte, again, it's just a fee, a way of being able to set the fee, is enough. So I'm not going to bother too much with that. And then this is just giving us some information about recent blocks that were found in the blockchain. Right down here at the bottom, we can see a very small diagram, which is what we're actually doing. So we are spending an input, and with Bitcoin, you always spend, or in other words, in a way, destroy the spending capability of a particular input in order to create a new output. And this output would then be used as the input for a further transaction that we might create in future. And then, so there's two amounts, and then the other amount is the fee. So in this case, we're spending 120 sats in order to send this transaction, which sends 1,000 sats. And we are consuming this output here, which contains 1,120 sats. So that's kind of what we're actually doing. Now, if I click Create Transaction, we can again see the same diagram here with the same amounts. All right, and then we can finalize it. There's a whole lot of details that we can change. We're not going to do any of that now. And now we can go ahead and sign. And I'm going to click the sign button here. You can see there's a number of different ways you can sign. If we had a hardware device, we would be clicking this to show a QR code, perhaps, which we would scan with a camera, or we would be saving it to an SD card. There's different ways you can interact with these offline hardware wallets. But this is, of course, a wallet where all the private keys are contained within the wallet. So I'm just going to click the sign button. You can see that this one then signs. It's going to ask me, do I want to connect in order to broadcast, which I'm now doing. So now it has basically connected me to a server, and I can now broadcast the transaction. Now it has gone into the blockchain, or not quite yet. In fact, it's actually still unconfirmed. That's shown here. This here is actually the transaction hex that is added to that blockchain immutably forever, right? So this is the actual information. So Sparrow is showing you quite a lot of information that maybe you don't need, but it's quite helpful to be able to get an idea of actually what it is that you're doing, and you can kind of learn how Bitcoin works over time. You can go into details here. You can see we spent one output, a whole lot of details here around the Bitcoin script that was used to spend this particular input, and then the Bitcoin script that was created for the output. So there's lots of details here. You don't need to understand them or know them, but they give you information should you wish to know more. If we go back to our JavaFX wallet, we click on transactions, we can now see that amount that has come in, that 1,000 sat amount that is still unconfirmed. And in about 10 minutes or so, we should see that confirm on the blockchain, and then that amount becomes immutably kind of set and is then ours. So this is how one can transfer value around using Sparrow.
So we're looking at a wallet. This has nothing to do with the mining of Bitcoins. That's something which happens on more powerful machines somewhere in the cloud, probably. So this is really how you create transactions and see them and receive them.
That's correct, yes. So mining happens with very specialized hardware. You can do it yourself. You can buy actually very small devices which enable you to mine yourself. But generally, mining is something done by other people, not by users. There's a growing number of users who really enjoy getting into that space, but that's not what Sparrow is doing. Sparrow is really just about sending and receiving and managing your money.
I've seen some fancy things in your application, like the diagram itself, like the notifications popping up. Did you implement all this yourself, or is this using some libraries?
I think it's to be honest, a mix. The diagram is implemented myself, with obviously using JavaFX natives. The notifications is, if my memory serves me correctly, controls effects. I might be wrong on that, but there's just been various things that you kind of have to use in the Java world, as I'm sure many people know. You kind of have to make the leap from the integration, from the kind of native Java space into the desktop space, and it's often you need some kind of method of doing that.
How did you solve the challenge of installing the application? Because a lot of people are struggling with, I have a jar, I have my finished application. Now, how do I deliver this to the end users? How did you solve that?
I use JPackage for that. So JPackage is bundling the app up. In fact, it's actually creating the installer as well in all the cases except for macOS, where the DMG, I just use a different application because I found that the JPackage one wasn't quite sufficient for what I needed. But otherwise, JPackage is a very capable system, I find, for creating, if you will, retail level or user level kind of packaged apps.
I also saw on the website you have the Sparrow Desktop application, so that's the one you just showed, I guess. But you also have the Sparrow Server. So what's the goal of the server application?
The server app application really just takes the basic functionality within the desktop application and puts it into a terminal interface. So you can't send from that. All that you can do is really just view the wallets that you have, but it allows you to kind of do some basic wallet setup and to be able to see much the same screens, but just in a terminal kind of interface. And I use Lanterna for that, just to kind of give you that terminal kind of experience. So you can run that on a server without any kind of desktop UI.
Is this also a bit the advantage of using Java and JavaFX? So you have the whole logic, what is happening with the wallets, I guess, is just pure Java. And then you have the JavaFX UI on top of it to visualize it. Is this how you could easily create both a desktop and a server using the same logic?
That is true. There has been a bit of an issue there in that the last version of JavaFX, which supported headless running, was actually JavaFX 18, because after that we started to lose the Linux compiled binaries for the headless, what was called Monocle. So luckily that is now coming back with the next version of JavaFX. So I've had to kind of keep the server version running on JavaFX 18, and I haven't been able to update to use the more recent API features on the desktop side because of this. But now, as I say, there's a new way to run JavaFX in a headless approach, and I'm very much looking forward to using that.
You use Java and JavaFX to create this application. Why? What was the main reason to go this path?
That's a great question. So it turns out that much of the Bitcoin world is really in love with Rust. And there's many good reasons to love Rust. Rust has obviously got many excellent use cases, but there's one area in which Rust is not great, and that is in creating desktop applications. So when you are using a Bitcoin wallet, you typically want to be as far away from your browser as you can be, because a browser, in definition, is taking random code off the internet and running it in hopefully what is a sandbox space. But you don't really want to be trusting your money to that kind of thing, to random code running off the internet. You want to have a desktop application. So staying away from the browser has been proven many times over to be the right approach. So you need to have a good desktop GUI framework in order to be able to create a professional and competent app. And that's one area where Rust is not great. In fact, I would say most languages aren't great. So that's one area where, for me, Java has always been very forward thinking. So I was using desktop with Java all the way back to AWT days, and I've kind of used it through the Swing days and now through JavaFX days. And for me, it's been through so many iterations. I mean, I've just mentioned 3, but there are more. It's been through so many iterations that I think we've really achieved a level of high performance, but also high capability that I think is not easily found elsewhere. And that's one thing that I think most people don't appreciate when they are choosing what language should I write my new project in. And I often make this argument to other Bitcoin devs, and I just get these blank kind of looks on the face of, I didn't think about that, because, it is really, if you look at the amount of work and effort that goes into JavaFX, you just go on the mailing list and you see the number of posts every day of just really high professionals or highly skilled professionals working on this. It's really quite different from, I would say, the vast majority of what other languages have. So that, for me, is one of the major factors.
And what people don't realize is how much security work is done within Java and JavaFX. So if you're on one of these LTS versions, like 17 or 21, the 17 you download now is completely different than the 17 which was released initially, because every 3 months you have these security updates, these builds with security fixes in both Java and JavaFX. So I can definitely believe why you think security is, I think, the main important topic for your application. If you're working with the money of people, then having the most secure environment to run it on, it's the top reason, I think.
Yes, it is. It really is hugely important when it comes to an app like a Bitcoin wallet. One of the areas where I'm really happy that Java shines is to be able to reproduce the build. So we have an important characteristic, and all Bitcoin wallets get tested against this. You have to be able to create a exact bit for bit replica of the build that is the released version. Otherwise, what is the developer doing behind the scenes, right? So that build reproducibility is really important, and I'm very glad to say Java allows me to do that. So the version of Sparrow that you download from sparrowwallet.com should be, except for when we have to, on Mac OS sign it. Obviously, that's not something we can reproduce. But apart from that, if you, for example, download the Linux version and you build it yourself, you'll get exactly the same files.
Okay, this is part of the whole discussion about S-bombs and reproducible builds, which is ongoing for a lot of business applications. So I'm amazed that you are doing this for free in a free app.
Yeah.
Why are you doing this?
Well, it's simply you just have to do it. So
Mhm.
the Bitcoin ecosystem is quite technical, as you would imagine, and really demands it from any serious Bitcoin wallet. You know,
Mhm.
if a Bitcoin wallet doesn't have this capability, then it really, you do have to wonder. It's really comes down to trust. So Bitcoin is all around not. It's not about making it trustless, but it's about trying to minimize trust. So you as a user do not want to have to trust me. You want
Mhm.
to ideally be able to see, here is the code. I can verify what it does by looking at it. I'm going to run this code, and I'm going to see that everyone else is running the same code
Mhm.
because we can build the same file. So it just comes down to the fact that in order to build a decent Bitcoin wallet, you really do need to have to think about these
Mhm.
things.
You mentioned on the website it's free, it's open source. Is this a pet project for you? Do you make any money out of this? Because you're not asking for money for it. So how can you keep this alive, this project?
Largely because it was never designed in that way. It's not
Mhm.
a commercial venture. I'm lucky enough in life to be able to spend time on it, and it allows me to really take part in what I think is the evolution of money, which is a hugely exciting space to be in. So it gives me a lot of personal satisfaction to work on it. But beyond that, there is a lot of grant money in the space. People, who come into it can, if they have a good idea, can apply for that. There's organizations. One of them, for example, is called OpenSats, which allows you to apply for a grant. There's many different ways for an open source developer in the Bitcoin space to be able to contribute over many years, largely because there is a strong, I think, foundation of commitment to making
Mhm.
Bitcoin as itself succeed.
Great work. Thanks for doing that. So you're an active JavaFX user. Are there some parts in the code that you're really proud of solving a specific difficult problem or something that you think I haven't seen this before?
I would say, there's nothing dramatic in there. Right now, I would say the area of Sparrow that I'm proud of the most is really just the UI. I
Hmm.
think making an intuitive UI for something as complex as interacting with the Bitcoin blockchain is a challenge in itself. You've got, you know, all these different hardware wallets, many of which interact in their own ways. You have just this constant complexity of people using Bitcoin in different ways, and you have to really always reduce that down to, how do I create a user experience that is convenient, that is simple, and that is easy to understand. And hopefully, what I did earlier, just taking you through the basics of the wallet, kind of, even though it was very quick, just kind of gave you an idea that this is not a super difficult thing to
Hmm.
do. That's, I think, the area which excites me the most and has always interested me the most, is being able to create UIs that are intuitive but educational at the same time.
You showed a use case with these 12 words. You also mentioned a lot of hardware devices. So how can I secure my money with Sparrow in other ways than just these passwords?
Sure. So we have all kinds of different hardware wallets. I'll show you one right now. This here, this rather imposing looking
Hmm.
device, is a cold card queue, and this is really a very capable wallet. So it has, as you see, the full keypad there. It has actually a little QR code scanner at the top, and it has a fairly large screen, so it can also show QR codes. So with this device, it also has two batteries here at the back, so it's kind of powered itself. That device is completely offline. It has two secure elements on it, and it allows you to basically store those 12 words within those two secure elements. And that device, you can never connect to any computer. So it's really just its own little isolated computer, very simple one, of course, which sits apart. Now, that ensures that you're only ever communicating with Sparrow using QR codes. And the amount of information on QR codes is very small, and we really limit it. So that device then becomes the thing that you trust to keep those 12 words safe. The amount of security in the device that I just showed is really quite amazing. It's many iterations. There were many versions of cold cards leading up to the one that you just saw, and it's really a very professional and very high level security. If you go and look into it, you'll find there's all kinds of ways of which people have thought about how can this device be made better and more secure and help you against various kinds of threats.
And it's just another way. So you could also have just a USB key with this 12 words and then hope you never lose it or it never breaks.
You can, yes. I think it's always better to use some kind of a device. I think that there are various ones, some of which, as you say, you plug in. There's a device called Trezor, which also allows you to communicate with Sparrow, but that one you actually plug in via USB. They all have different trade-offs, but by and large, in this kind of day and age, we really have a wide set of devices, and they're all pretty good. They all kind of really have learned from each other and raised the bar over the years. So now we're in a pretty advanced state where you can get a device for a reasonable sum, and it will last you for many years and keep your funds very secure.
Yeah, it's a fascinating world. Like this device, is this also open source hardware, software?
Yes, so the devices, hardware and open source is a difficult thing. So if you really get into the weeds of it, there's a lot around the secure elements that they actually don't allow full open source to. But there's also a Bitcoin company that has just created a fully open source on a hardware level secure element chip. So that's very new in the space, and that's great. So there's been levels of open source sourcing, and we're always marching towards making everything as trustless as we can. So we are, the hardware for the cold card contains 2 secure elements, which are not fully open source, but the rest of it is, all the way down to the software as well. And there's no way that you should be using a hardware wallet which doesn't have open source software, or at least source viewable software running on it.
If we go back to the Bitcoin system itself, so the blockchain, can you briefly explain how it works and where Sparrow connects and handles the transactions?
Sure. If we look at these transactions here, as I was saying previously, every time we spend a transaction, we consume an input to create an output. And that's really the way the entire system works. So let's go back to the one that we had created earlier. We have this quick test received as an input and then going to this output here. Now, what I can do is now create an amount, a new transaction based off this amount that I sent. So if I go into here, you'll see that I go down to this and I can send this amount here. So what I'm going to actually do is take you down to this tab. Now, a UTXO is a long kind of acronym, but all that it actually stands for is an unspent transaction output. So again, here, this is a transaction output. This is a transaction. This is one of the outputs, and we haven't spent it yet. So UTXO is just an unspent transaction output. And we have one here, an unconfirmed one, but we can spend it anyway. So if we spend it, we're going to click that button. We can now send it back. This time, I'm just going to select a wallet. I'm going to send it back to the previous wallet. And I'm going to give it a name like back. And now you will see that it is now taking that transaction output as the input to a new transaction. And of course, we have to include a fee every time. And then we have this new output we have labeled as back. And that will now be 890 sats because, of course, we have to include the fee, which is going out here. So every time in the Bitcoin blockchain, and I think that this is the point I'm trying to make, is we are now effectively spending this output that we just created to create a new output, right? So this one becomes an input and this one becomes an output. Now, if I was to go back to that transaction again and I was to look at the inputs, right, it now gives us the output. And this is called an out point, actually, because what we are doing is referring to the transaction ID and the transaction, the sort of index, which is 0. And then that spends this amount from that address. That's a lot of detail. Don't worry about it too much. It's just to say that all we're trying to do here is this is how Bitcoin works. And I think it's very important for people to understand it, because there's a lot of ramifications that come from understanding how this whole system works. If we are spending in a slightly more advanced example, for example, if I go back to this wallet here, perhaps I'll be able to see, here we have a different transaction where we actually are sending change back to ourselves. So here we have an amount which is a bit bigger. We have, 493 or so thousand sats, and we are spending an output which is 110,000 sats. But because we are spending the entire amount of this particular output here, we have to send change back to ourselves, and we are creating a new output which contains the change. So that's really how we do it. It's not an account-based way of thinking. So with an account, you kind of just have a balance, and that balance either goes up or down. But what we're doing here with the Bitcoin blockchain is that we are creating outputs, spending those outputs to create new outputs. And once you get the hang of that, then a lot about Bitcoin becomes a lot more easy to understand.
Yeah. So it's not like I have on my normal account 1,000 euros. I will have in Bitcoin a set of amounts I still need to spend.
That's correct. So if I go back to all the UTXOs in this wallet, you can see I have a bunch here, right? And these are all different ones that I've sent into this wallet, or other people might have sent in a different case, that have been accumulated over time. You can see these have all come in over different periods of time. And these all refer to the different outputs that have been set. So this, again, is the transaction ID, just a shortened version, and then a number, which refers to, again, is it number 0? Is it number 1? That's all that we are seeing here with this 1 and the 0. I can open this particular one up. I can have a look at it, and I can see, that's the amount. That was the change amount. That's the transaction ID, and it's number 1. So that's really what we are sending back to ourselves in order to get this particular UTXO, this unspent transaction output here.
So if you want to send a certain amount and you don't have one transaction which has enough left, you need to combine several of them to reach a certain amount. Okay.
Yeah. So let's say we didn't have this big one at the top, and we wanted to spend over 10,000 sats. We could then select all of those, right? We're going to need a little bit more than that. And then we can basically send all of those at once. So I'm just going to create a simple transaction that sends back to us. And you can see here how we basically now have a transaction which has all of these different amounts in it being combined to create one output, right? And then that allows us to really manipulate the kind of value that we have in the wallet and do various things over time. It's actually quite useful to create this kind of transaction back to yourself when you have very small valued amounts like you do here, because these, the way that the fees work is that the size of the transaction in bytes is actually the determinant for how much the transaction costs. So it's not the value that you send, but rather the size in bytes, because we're dealing with this structure called a blockchain, which is in every way highly inefficient, where we all have to share a copy of this global ledger, which is shared everywhere around the world. So the greatest cost is, of course, sharing this information. And that's why the Bitcoin blockchain makes you pay a cost for the size of the transaction, because actually that's really what the real cost here is sharing this information. So this particular transaction would have actually costs more. If you remember, the last one we sent was 120 sats. This one's 584. The reason that it costs more is because it's so much bigger, because we're combining all these different inputs. So, in effect, I'm paying more. I actually can't send the full 10,000 just because of the fee on this particular one.
And this fee, you can select it, the range, or
yes.
is this a
so
fixed?
you can slide this up and down. Now, this is just a multiplier. So currently, we're paying 1 sat for every virtual byte. A virtual byte is just a slightly modified version of the size of the transaction that we have. But if we were sending, and lots of people were trying to send at the same time, effectively, they're all trying to compete to be in the next block, right? And what you can do here is outcompete people simply by paying more. So you're increasing this fee amount here by sliding this up. Currently, we're on 584. If we slide this up and we pay 4 sats per VB byte, we are now spending quite a lot more in terms of sats in order to outcompete everyone else. So all that you're trying to do here is actually just predict the future, right? We have these different blocks which are coming in, and we're trying to understand what is going to be the minimum fee necessary to get into the next block, if that's where if we want our transaction to confirm on the blockchain.
And when would we want a higher priority?
If you're sending money to someone else and it hasn't been confirmed on the blockchain yet, it's not really theirs until it's been confirmed, or at least it's not. I guess the best way to say it is it's just not a confirmed send.
Yeah.
So you'll find that if you're sending to a vendor, for example, or a merchant, they will require at least one confirmation, as we call it, before they release the goods, because they want to know that this transaction can't be reversed. Now, it turns out that actually what you can do before a transaction has been confirmed is you can do something which allows you to send it back to yourself. You can actually basically increase the fee, or you can change the address that it sends to, because it hasn't been confirmed on the blockchain yet. It's just sitting in the memory of all these different nodes all over the world. And if I then change it and send it back to myself, so I'm going to change the address, I'm going to increase the fee, then and I broadcast this particular transaction, all of those nodes all over the world take the updated version. And of course, because the Bitcoin miners want to make more money, they take my more expensive version of the transaction, which spends the same input. And then that one is the one that's confirmed on the fee. So for all of that reason, you really want to wait for your transaction to be confirmed on the blockchain before you know that that money has been transferred to you. And the same goes for the merchants. They want to know that that money has been transferred to them. And that's why you kind of have to wait for that first confirmation.
If I want to get started with Bitcoins, I don't have any, but I have some cash here. How do I convert that cash into my first Bitcoin?
The common way that most people do it is go to whatever the local exchange is. So if you're in Europe, you might go to Kraken or Bitstamp. If you're in America, you might go to Coinbase. But it really just depends where you are in the world. There'll be a particular exchange that has dealt with whatever local financial regulations they are in order to be able to set up there. So that's the normal kind of approach that most people will have. Now, when your Bitcoin is sitting on the exchange, it's not really yours in the true sense that it can be, right? It's like a bank in the sense that the bank is saying, I owe you this much money. You have deposited this much money for me, and I've given you a slip saying this is the amount that you have deposited for me. An exchange is very much the same, except it's actually less protected than a bank, right? So it's not the greatest place to hold a large amount of money. By all means, a small amount, but you kind of want to get that off the exchange into a way in which you can hold it yourself. And the great benefit of holding Bitcoin yourself is that it really then becomes yours in a way that we don't really experience with the monetary world that we've all grown up in, right? We've all grown up with cash, certainly, and cash is very much ours. You can think that of Bitcoin that you transfer off the exchange to be very similar to cash in the sense that it's really yours now, and you can take it anywhere in the world. Obviously, with cash, that's less useful. If you take euros to America, you probably can't use them there. Bitcoin you can use anywhere in the world. So it's more usable. And it kind of gives you a lot of flexibility to be able to do it. So really, that's what Sparrow is there for. Sparrow is for when you have bought Bitcoin on an exchange or from a friend or what have you, and you want to own that money yourself in the way that you have actual cash in your wallet.
And that's where Sparrow then gives you a wallet, and that wallet ID can be used on that exchange where you have bought it to get it to your own PC.
Yeah, so what you would do on the exchange is, for example, with my JavaFX app here, you would go into receive, you have an address there, and that you just copy that in, you copy it into the exchange, and you ask them to send to that address the Bitcoin that appears in Sparrow. And from that moment on, it's no longer on the exchange. It's now held by you within Sparrow and secured by those 12 words that you wrote down earlier.
And that's what your tool makes available in a secure way.
That's right, yeah.
Thanks to Java and JavaFX.
Absolutely.